This question is very AP style. It's probably a multiple choice scenario, but the idea of you being asked about differentiability, that implies continuity. So we are dealing with a system of equations here because we're going to have two equations, one that deals with continuity, right, and one that deals with differentiability. So I'm going to go ahead and make that note over here, implies continuity. So what does this mean? How are we going to start working with this, diagnosing how to work with this, right? Oh, that was a terrible bracket. All right, so first of all, what does continuous even mean? Well, continuous means that the values are equal. So that means that one of the quadratic has to be touching the line, right? Values are equal. So this guy has to be equal to this guy at 2. But what does differentiability really mean? Differentiability is about the slopes. So differentiability means the slopes, or the derivatives, however you want to think about that, or the derivatives must be equal from each side. Because if the slopes are not approaching the same value, then I'm going to end up with some sort of sharp turn. So that's how we're going to set up our system. We're going to do a continuity equation, and then we're going to do a differentiability equation. So let's work with continuity first. It's a little bit more straightforward. Continuity. I'm worried about what's happening at x equals 2, because this is continuous by itself, and this is continuous by itself. These are polynomials, so I'm only worried about what's happening at 2. So I'm going to say that ax squared plus 1 has to be equal to bx minus 3. And now I'm going to plug in a 2 for x. So I'm going to have 4a plus 1 has to be equal to 2b minus 3. Now I still have two unknowns. So I'm going to be dealing with some sort of system. I might want to move the b over and do some sort of elimination. I might want to use substitution. But I'm not going to go too much further into that until I figure out what my differentiability function looks like. So differentiability is a little bit different. You are going to have to take the derivatives first. Did I spell it right? Differentiability. Okay. Sometimes I get a little lost in that. So we need to find f prime of x. So let me go ahead and slide this over. Just because it's piecewise doesn't mean I can't find the derivatives. The derivative of the top function is 2ax, right? Oh, I was going to say plus 1, but that's not true. Okay, so 2ax, and then x has got to be less than 2 for that derivative to be true. And then the derivative of bx minus 3 is just b. Remember, if that was a number, we would have that constant. So I'd have b as long as x is greater than 2. So I need those two equations, again, to be equal to one another when x is 2. So again, I'm going to say at x equals 2, I need 2ax to equal b. That means the slopes, it would make a smooth curve. Ultimately, that's what's happening. So when I plug in a 2, I get 4a equals b. Well, that's going to be pretty simple. I can just use substitution, right? So if b is equal to 4a, then I can just plug a 4a in over here. So 4a plus 1 equals 2 times 4a minus 3. Now just a little bit of work. 4a plus 1 equals 8a minus 3. Do a little bit of subtracting. Negative 4a. I'm going to subtract this one over here, right? Equals negative 4. So it looks like a is equal to 1. So if a is equal to 1, I've done part of my job. I got to go finish it. So if a is equal to 1, then 4 times 1 obviously would give me b. And that means b equals 4. So these are the values that create a continuous and differentiable piecewise function. This is really important that you recognize that differentiability implies continuity.